Page 279, number 19. A Ferris wheel with a radius of 10 meters rotates once every 60 seconds. Passengers get on board at a point 2 meters above the ground at the bottom of the Ferris wheel. A sketch of the first 150 seconds is shown. Write an equation to model the path of a passenger on the Ferris wheel where the height is a function of time. I've drawn this diagram over here just a little larger so we can label some points on it. If we're given the radius of a Ferris wheel, remember that the radius will give us the amplitude. So we know that the distance between the max and the median, or the median and the min, is going to be 10 meters. Rotates once every 60 seconds, so because that's one rotation, that gives us the period. And passengers get on board at a point 2 meters above the ground. So this is where the passengers would get on, and so this must be at 2 meters. So once we know that's 2 meters, because the amplitude is 10, we can add 10 and know that our median is at 12 meters. We can also add 10 again, just to show that our max is at 22. So we've got our A value, our D value, our period can give us our B value, 2 pi divided by 60, so we have pi by 30. And now we need to write an equation and look for the C value. Because the passengers get on at the very bottom, if we start at the minimum, we'll use negative cos. So putting our equation together, I'm going to use height as h. I'm going to call this h of t. Negative cos, I'm going to put a negative 10 cos pi by 30t plus 12. Now let's look at question B. If Emily is at the bottom of the Ferris wheel when it begins to move, determine her height above the ground to the nearest tenth of a meter when the wheel has been in motion for 2.3 minutes. So we want to find the height when the time is 2.3. Now, when we have our diagram here, remember the period is in seconds, so that means the time that I insert into the equation must be in seconds. So we have to take 2.3 minutes and times that by 60 seconds, which gives us 138 seconds, so that's what we will be plugging in. So we're plugging in h of 138 into our equation. Remember that when you're putting this into your calculator that you will want to have everything in radian mode. When we do that, we get an answer to the nearest tenth of 15.1 meters.